Hello and welcome to Chapter 8, Section 4, which is Multiple Representations of Functions. This is on textbook page 603 to 606, and I'm just going to remind you to copy everything. Let's get started. All right, on textbook 603, this is where you should be. You should see the little dinosaur head right up there, and I'm circling the textbook page number now. All right, so let's get started. It says a group of friends are going to the museum. Each friend must pay an admission price of $9. So you see the $9 there. Then it says complete the table and graph the ordered pairs, number of friends, comma, total cost. Now before we get started, I want to point this out right here. Number of friends, comma, total cost. I'm circling that because that is so super duper important. When they give you that information in parentheses like that with a comma, they're telling you that's the order it has to be in for your ordered pairs. So what that means is, let's see here. So one person is going to cost $9. So see how you have the 1 here and the 9 here? So it's going to be 1, comma, 9 because number of friends, and let me just go ahead and color code that better. So the number of friends is going to be right here. These are all your X values. And then we'll do this part in pink. These will be all your Y values. So one friend will cost $9. So that means your ordered pair is 1, comma, 9. Let's go ahead and make that, Let's go ahead and make that look a little more normal. All right. So if one friend costs $9, then that means 2 friends cost $18. 3 friends cost $27, and 4 friends cost $36. I'm just going to erase this so that we have some room here. $36. All right, so now we're going to make those ordered pairs given that information. So 1, 2, 3, 4, comma, comma, comma. So now in green, we're going to show you 2, 3, and 4. And when X is 2, so when the number of friends is 2, which is right there, then that means Y is 18. When X is 3, Y is 27. And when X is 4, Y is 36. So now you're going to plot these on the graph. So let's go ahead and do that now. Right, so the first one is going to be over 1 up 9. So it's going to be about right here. It's hard for me to get it on there correctly. The next one is over 2 up to 18, so it's about right there. The next one is up over 3 up 27, so it's going to be about right there. Whoa, that might be a little high. Hold on. So over 3 up to 27, which is probably good right there. That might be a little high. I just can't get the stylus here to work better. And then over 4 up to 36, which would be right here. Whoops. Whoops. Okay, so I'm not super good with the stylus with that close of a picture. So this is what it should look like. And here we go on the next page, it's a little bigger. So again, let me go back here. We've got 1, 9, 2, 18. Whoops. Hold on one second. All right, so now you can see it's a little bit better now. So here we go. And you want to make your line as straight as possible. Then it says to describe the graph. So in describing the graph, we're just going to say that the ordered pairs lie on a line. So you want to go ahead and write that there. And then for number 3, it says to write an equation to find the cost of N tickets. Okay, so what I've done here is just, you don't need to write this table because it's already above, but just so we knew what we were working from, I wanted to have that here for you. So we need to establish the relationship between 1 and 9. So we could add 8 or we could multiply by 9. So let's look. If we added 8 to 2, that would give us 10. But since we see 18 here, we know that the relationship has to be multiply by 9. So remember, because we're writing a function, it's going to be y equals, so we put it in y equals format, and it'll be y equals 9x, because we're going to take whatever x is and multiply it by 9. And then it says to find the cost of N tickets, and let's go ahead and put that there. Okay, and here you see y equals 9x, where y represents the total cost and x represents the number of friends. All right, on the next one it says, list the ordered pairs for the cost when 5 friends go to the museum. Describe the location. So when 5 friends go, we're going to take our equation, which was y equals 9x, and we're going to put y equals 9 times 5, y equals 45. So the ordered pair would be 5 friends and $45. So now we'd go over 5 and up to 45, which is right there. It is 5 units to the right and 45 units up. So that's the description. All right, so on the next slide is when you'll see the description that you need to write for number 4. So this is what you need for number 4. So you want to make sure to write that on the line. All right, moving on to textbook page 604. Okay, so here we see that we're going to be representing functions using words and equations. So words and equations. A runner's distance in a marathon is equal to, so there's that word equal, 8 miles per hour times the number of hours, and then the distance. So what you'll see here is that distance is for D, obviously the equal sign, and then 8 miles per hour, that's where they get the 8, times, that's why it's right next to it, and then the number of hours, which they represented as T. And it says words and equations can be used to describe functions. For example, when a rate is expressed in words, so a rate, it can be written as an equation with variables. When you write an equation, determine what variables to use to represent different quantities. Just a reminder, don't black out the equation portion. The 2 lines that I blacked out, you don't need to do that. I just do that so that the answer isn't staring us in the face. So this says the Drama Club is holding a bake sale. They charge $5 for each pie. So see, you have that $5 for each pie. You know that's probably going to be listed with a variable because each pie is $5. So then it says to write an equation to find the total amount earned, which is, they've said, hold on, I kind of wrote over it. The total amount earned, T, for selling P pies. So here they've already told you what the variables are. So you can see that the total equals, this is how they would like it in words. The total equals 5 times the number of pies sold. So then let T represent the total earned and P represent the number of pies sold. So then you would come up with T equals 5, P. Okay, let's see what they got. T equals 5 times P, which is T equals 5P. All right, in example number 2, it says, in a science report, Mia finds the average adult breathes 14 times each minute. There's that word each again, when not active. Write an equation to find the total breaths, B, so total breaths, B, a non-active person takes in M minutes. So they've actually already given you B and M. So in words, they want you to say, let B represent breaths, total breaths, and let M represent the number of minutes. So I've used the pink to show you that. So let's go ahead and do that here. So since B is going to be with that word total, that's how we know that's the one that's going to go by itself. B is the total, so it goes by itself. So B is equal to the number of minutes. So it's 14 times each minute. Whoops. So it's 14 times the number of minutes, which would then be B equals 14M. Okay, and as you can see, that's what they got as well. All right, you want to pause the recording here, and then you want to go ahead and try A and B on your own. A mouse can travel 8 miles per hour. So there's that word per or each. Let's go ahead and put a circle around that. Okay, we know that because it says per or each, we know that that's probably going to go with the variable. Oops. And by go with the variable, I mean it's going to be attached to it. So attach to variable. Okay? And then it says write an equation to find the total distance, d. So they've already identified this, d. And remember, because it's total, it's probably going to be by itself, d equals, a mouse car travels in h hours. And remember, we have the second one here, which is h hours. Now remember, we'll go ahead and do the h hours right here. And remember, they travel 8 miles per hour. So that red that we had earlier, I'm actually going to make that turquoise so it's here. So it's going to be the 8 miles per hour times the number of hours that they travel. So then your final equation will be d equals 8h. All right, on B it says Samantha can make 36 cookies each hour. There's that word each again. Remember, that tells us this is probably going to be attached to the variable. This is usually the easiest one to identify. All right, write an equation to find the total number of cookies. So remember, they already told us total number of cookies, and they've even defined the variable as C. And remember, we said that the total is going to usually be all by itself, so you want to put C equals by itself, that she can make in h hours. And remember that they've already defined the h hours. So it'll be something times h. And remember earlier, what did we say was attached to the variable? It's going to be 36 for each. Well, let me go. 36 for each. So now we get C equals 36 times, 36h. All right, so you want to make sure that you have the 36 before the h, because remember, that's the coefficient. On the left-hand side of your page, you'll see a little green sticky and it says variables. You can use any letter as a variable in an equation. If you graph the equation, make sure to label the axes with the correct variable. So when it says you can use any letter, you can, unless of course they gave you the letter in the problem like they did in the last two. Okay, now we're on textbook page 605. All right, so now we're at the top of page 605, and it says represent functions using tables and graphs. So on the left we have a table, and it's got the time in hours, and on the right we have the distance, which is miles. And so this is the relationship between time and distance. And notice how in that last sticky, remember it said to make sure that they're labeled correctly. So see how we have time, which is represented with h right here. So that's that one, and it matches up. And then we have distance, which is represented with D, and that matches up right here. So you want to make sure that when you're creating tables and graphs that you match them up. All right, let's go ahead and take a look at example 3. It says the student council is holding a car wash to raise money. They are charging $7 for each car they wash. There's that word each again. So $7 each. That 7, usually that means that it's attached to the variable. So we are going to attach to variable. And that's just a little note on the side so that you remember that when you find that word each or per or for every, that's usually the one that's going to be stuck to the variable. It says write an equation, so that's our first step, write an equation, and make a function table, so that's our second piece, to show the relationship between the number of cars washed, C, and the total amount earned, T. And remember what I told you before about total. The total is usually by itself in the equation, or in the function. So you could, and actually it's asking us for an equation. So usually the total is by itself, so you're going to do T equals. Remember we said that that's 7 because it said $7 each is usually attached to the to the variable. So it's going to be 7, and then the number of cars washed is C. So our equation is T equals 7C, and let's see, they said, so the equation is T equals 7C, which is what we got. Then it says the total earned output is equal to 7 times the number of cars washed input. So to make the table, you would just put in the 7C right here, then you would plug in 1, and then you would get 7, 2, and 14, and so on. Okay, and on the right-hand side, you see a little stop sign, and it says stop and reflect. What are the independent and dependent variables in example 3? Explain below. Okay, so in this example, the independent variable is going to be C, And the reason it's C is because the number of cars can be any number that you want. But then the total output, which is T, the total made, total money made, depends on C, or the number of cars. So that makes this one the dependent variable. Okay, so for example number 4, it says to graph the ordered pairs and analyze the graph. Find the ordered pairs CT. Now again, remember when they give you the order, that's very important because that's the order that the ordered pairs come in. So the ordered pairs are 1, 7, so just erase there. That means 1 over 1 up 7, and then it's going to be 2, 14. And you should be able to see all of those now. Please don't black anything out that I black out. I'm only doing that so the answer is not right there. And it says the graph is linear because the amount increased by $7 for each car washed. So this makes it a linear graph. All right, now we're on textbook page 606. So you just want to identify textbook page 606, and we're going to zoom in on the next slide. On textbook page 606, it says, got it? Do these problems to find out. So you want to pause your screen now, pause the video now, and try this one on your own. All right, so on your own now, you were supposed to have looked through and done C and D. So it says, while in normal flight, a bald eagle flies at an average speed of 30 miles per hour. Remember, there's that per or the each, so we know this is probably going to attach to the variable in our equation. Okay, so I'm just going to write that little note here. Then it says write an equation, variable. Write an equation and make a function table to show the relationship between the total distance, D, so total distance, D, and remember we said that D is usually alone, and that a bald eagle can travel in H hours. So remember H is the variable, and remember we're usually going to attach that per or each number there. So the equation we've actually already come up with, which is D equals 30H. So we can write that right on the line right here. D equals, let's clean that up a little bit. D equals 30H. And then it says graph the ordered pairs because you were supposed to make a, you were supposed to fill in the table right up here. So for 1 hour, if we put a 1 in right here, we can do 1, 2, and 3. Actually, let's go ahead and do, let's do 2, 4, and 6, just to shake it up a bit. So now, I actually went ahead and changed it back to 1, 2, and 3. And the reason you need to do that is because you're going to run out of space if you don't. So we should do that now. And what we need to do is notice that when we plug in 1 for H, let's go ahead and write our equation here. D equals 30 times 1. So that's that. So then that means that the total distance, D, equals 30. So now the ordered pair that you're going to have is when when H is 1, D is 30. So you have over 1 and up to 30 right there. And you want to do that for the next one. You can see that I've written that there. I did D equals 30 times 2. So when the H is 2, so that when they fly for 2 hours, then that means that the distance that they've traveled, 30 times 2 gives me 60. So I'm going to put the 60 in there, which means I'm going to go over 2 and I'm going to go up to the 60 and make a dot. Let's go ahead and do the last piece. Okay, for the last piece, you can see right here that we did D equals 30 times 3 because of this 3 right here. And when we plug when we plug the 3 in for H, we get 90 is the distance. So now our ordered pair is going to be when H is 3, distance is 90. So we're going to go over 3 and we're going to go up to 90. And again, those ordered pairs can be made from the table right here. So we've got 1 and 30, 2 and 60, 3 and 90. Okay, so now we're looking at the guided practice, which is on, again, still textbook page 606. You want to do the guided practice, including, you can do all of number 1 and the rate yourself. You don't need to do number 2 today. So don't black it out, but you do want to do all of one. So that means all of this. Please don't put a box around it. I'm just doing that right now for your benefit, so you know what I'm asking you to do. So I want you to do this, I want you to do this, all of this, and then I would like you to rate yourself. And I look forward to seeing you next class period. Good luck.